Yeah, right. 6-LoWPAN. What do you mean by 6-LoWPAN? We shall discuss here. Is it my slides are visible, ma'am? Yes.
Yeah.
Yes, ma'am. Okay. So what is that 6-LoWPAN? It is one of the type of protocol which is having okay, low power consumption is the major advantage of using this 6-LoWPAN, and in we find different protocols and standards like 6-LoWPAN, LoRa, and Sigfox. And there is an abundance of wireless technologies. And so, if your project requires low power consumption, and okay, so LoRa and Sigfox are similar to so it is having some similar characteristics. I'll tell you what are all those things further once I finish the 6-LoWPAN. And the name is similar to that, which both offer similar features but not necessarily the same results. Okay, so we have low power consumption protocols as these three: 6-LoWPAN, LoRa, and Sigfox. But we require this alone for our syllabus, right? So what is technology is 6-LoWPAN. What does it mean? IPv6 Internet Protocol version 6. IPv6 means Internet Protocol version 6, low power personal area network. So rather than being an IoT application protocol Bluetooth or Zigbee. Okay, so those comes in the category application protocol, where this is said to be wireless, low power wireless personal area network. And what is the special feature of 6-LoWPAN? We have a term called encapsulation, right? So 6-LoWPAN is a network protocol that defines encapsulation and header compression mechanisms. The standard has the freedom of frequency band and the physical layer across multiple communication platforms, including Ethernet, Wi-Fi, 4, and some frequency like ISM, which is required only one. What do you mean by encapsulation? So this is a major feature of 6-LoWPAN. This is a single unit. I think you may heard this term in C++ language. Okay, so the wrapping up of data. It is the mechanism that binds together code and the data it manipulates. Code and the data it manipulates. Okay. Another way to think about this encapsulation is it is a protective shield that prevents the data from being accessed by the code outside the world also. Okay, if you made encapsulated wrapping up of data, so it acts as a protective covering. Okay, and one more technique we used here is header compression. So this is a mechanism that compresses the IP header in a data packet before the data is transmitted. Okay, and this reduces network overhead and speeds up the transmission of real-time transport protocol and transmission control protocol. So why we need compressing the header network as well as speed up the transmission of transport protocols and TCP packets means that we could be capable of transmitting in a relaxed manner. There will not be any data loss. Then one more thing is are the benefits of using this 6LoWPAN? Efficient use of IPv6, that is Internet Protocol version 6, over low power embed. You can go for this low power wireless network, and this is ideal to create mesh network, as I said earlier. So this is very much suitable for mesh networking concept, right? It carries IPv6 or v4 data packets with some standards, and it also provides end-to-end IP, which provides seamless connectivity to a huge variety of networks using the same standard, okay, which provides data connection or direct connection. And low data rates. So low data rates in the sense, 6LoWPAN adopts a different approach to the other low power wireless sensor network solution. So this aims at providing wireless internet connectivity at low data rates. And low power in the sense, it provides a basic transport mechanism to produce complex control system and to communicate with devices in a cost effective manner. Okay, so what are the features behind all the benefits? It was given in that slide, and this is a diagram where we had a mesh network, and we have a node here. So this is providing connection with n number of nodes, and this is a 6LoWPAN network, and this is IPv6, and we have our edge router. We could be capable of in retrieving the information via the server, right, cloud. And coming for the applications, this would be applied for smart home, smart agriculture, and industrial IoT also. So smart home in the sense, connecting the devices using IPv6 has the chance to gain distinct advantages over other IoT system. So we have a thread initiative which is standardized the protocol running over 6LoWPAN to enable the home automation. And we have open thread, which gives developers a smooth introduction to thread. Thread in the sense that thread is defined to be a single unit of execution. Okay, thread is defined to be a single unit of execution. I think a few maybe know that a few or all maybe know that a Java language. There we have a concept called thread, which invokes the particular uh, part of the program. Okay, so that is possible with the help of thread manipulation, and using that thread implementation and 6LoWPAN, we can make smart home. Okay, by developing an application. And the another application is smart agriculture. This enables all kinds of sensors used in agriculture and farming by connecting the devices that are far away from each other in remote areas. Okay, and there are endless possibilities where the protocol provides when it becomes to building mesh network for this type of applications. Okay, so smart agriculture in the sense, we should sense whether the soil, we are using the soil, right, the soil content, the moisture content is enough or not. For that we can make use of some devices, or if you are providing water to the soil, right, so how much it is required. If you are giving more water also, so it will also spoils the plans. Okay, so based on everything and whether everything, so how to enable for each and everything, we have a sensor which could be capable of
Ma'am, voice is cracking.
identifying what is the moisture content.
Ma'am, your voice is continuously breaking.
I'm not audible. Am I audible, students?
It's
Ma'am,
continuously
actually your
breaking.
voice is breaking in between again and again.
I don't know why. Am I audible? I'm asking. Security, which provides link authentication and encryption. And top of the IP protocols, other security mechanisms such as TLS or digital signatures can also be implemented. Okay, so this is a simple protocol as concept head compression. So performs compression. Okay, it's the concept behind 6LoWPAN. And this is also this I brought it in the slide, so just you know. Yeah. LoRa and so this is one of the thing, right? So 6LoWPAN, something like that. We have a LoRa, which make use of that sensor as the technology again, right? LoRa is there, and so what is LoRa? Short for long range. Okay, it's a spread spectrum modulation technique derived from some spectrum technology which could be capable of providing low range. Okay, that's why we are calling it as low range, and it could be capable of performing in different. So we have a detailed study can be done which could be applicable for smart city, homes and buildings, communities, metering, supply chain, logistics, agri, everything. Okay, yeah, and yeah, a spread spectrum modulation technique derived from chirp spread spectrum technology. It's a low power wireless platform that has become uh, that would be useful for IoT. Okay, so that is that. And LoRa used for yeah, it is given. It would provide all the smarter applications. Can be used to connect sensors, gateways, machines, devices, animal, people, etc. wirelessly to the cloud. Okay, so that's why we are using that. And one more is Sigfox. You can see this Sigfox. So this is another network, like it's a global network. Yeah, which can wait. I'll show you. Yeah. So this is a in Wikipedia you can search some information about Sigfox. It's a French global network operator founded in 2010 that builds wireless networks to connect low power objects such as electricity meters and smart watches. Okay, so which need to be continuously on and emitting small amounts of data. Okay, so these are the two terms what I have used. Why I brought this? Zixlopan is similar to certain concepts what they are using. So it is also used for low power wireless technology. Okay, ma'am. So this is a small protocol or simple protocol which make use of encapsulation and header compression technique. Also, you should know how to define it. Okay. So it requires low power conceptions as and mesh network would be very much useful. Okay, so some features I brought it for you to explain about the 6LoWPAN with encapsulation as well as compression, header compression technique. Okay, and we have wired communication still, and yeah, we have wired communication that we have to discuss. I have not completed the document, so we will have it in next class. And we haven't discussed IPv6, I think, right? IPv6, Internet Protocol version 6, IPv6 6. So what is that? IP protocol version, Internet protocol. There are many versions available for Internet protocols, and V6 is a newer version of the network layer protocol that is designed to coexist with IPv4. Coexist in the sense it is not directly interwork. Okay, so it is existent, and the IPv6 provides improved internet-working capabilities compared to what is presently available with IPv4. Okay, so some enhancement was done for IPv6. Some enhancement was done for IPv6, and it offers the potential for achieving scalability. Scalability means we can add few more machines to the existing system. It is not going to affect the performance of the system. And reachability, whatever we are sending through source, that would be reach the destination. Proper end-to-end networking, like your point-to-point or peer-to-peer networking. The quality of service should be okay. It is it should satisfy certain standards, and commercial grade is needed for contemporary and emerging web services. Okay, and data services, mobile video, and IoT applications. So the IPv6 plays a major role in all the characteristics like that. Okay, scalability, reachability, end-to-end networking, quality of service, so and so. Fine. IPv6 address space. So how the address would be? The addressing architecture is described in RFC 4291 February 2006. Okay, and one of the major modifications in the addressing scheme is it could be capable of changing the basic types of addresses and how they are utilized. So like IPv6 is compatible to define addresses for new things also. So that is what given here in the different sentence. Scheme is there, addressing scheme is there. And there is a small, in this slide I brought what is the comparison between IPv4 and IPv6. IPv4, both are unicast. So here in IPv4 we have an ID for an interface mechanism, whereas in IPv6 we have N per interface. Okay, and explicit assignment is here, and this is based on some standards, IEEE standard. And if you're talking about broadcast and multicast, what are the thing? The limitation, right? 255 address, right? How will you assign addresses? And IPv6 is multicast also. Sometimes it is any cast also, like any ID for a set of interfaces delivered to the nearest one. Okay, any ID for a set of interfaces delivered to the nearest one. And some special purposes is also available in both the IPv4 as well as IPv6. So what is unicast transmission? What is multicast transmission? Unicast transmission is sent to this one specific address, and multicast is sent to every member of the specific group. Okay, and any cast is sent to any one member of the specific group. So by that way we could be capable of providing interface with IPv4 as well as IPv6. The transmission occurs to the closest member of the specific row. Okay, as you know, we have different algorithms like nearest neighborhood algorithm, k-means clustering algorithms, and I couldn't remember a few more. Okay, so k-means clustering and nearest neighborhood, something like that. So which is pointing closer? Okay, that would be grasp. Okay, soon. So that is the type of transmission occurs here. And I brought few things for a unicast, how the model would be, multicast, and anycast. Okay. So as I said, unicast is sent to this one specific address. Okay. And multicast is, we have every member, for all the members, for all they'll send it. Okay. And here the devices 1, 2 and 3 are part of the same group. So it is sending here. And here you can see, even though the connections are provided, it is sending only to C. Okay. And anycast is the device 1 and 2 are part of the same group. Okay. So it is sending only for one. And this is the address space. Um, yeah, it is 128 bits in IPv6, and in IPv4 we have 32 bits. Okay, the size of the address space. And special IPv6 addresses, like how will you address it? An auto return or loopback virtual address. So we have 127.0.0.1, something like that. This address would be represented in this manner. Okay, and there is no specified addresses. So how we are assigning the addresses? That is what given in the slide. So they are both are said to be tunnel addresses, dynamic and represented with few tables, ICMP, V6, neighbor discovery. So neighbor discovery only I told you, nearest neighborhood algorithm, or you can take k-means clustering algorithm, which could be capable of fetching the next node, right? Fetching the next node. And IPv6 compared with your IPv4, IPv6 has have some enhancement in their performance. So we can call it as a connectionless datagram protocol used primarily for addressing and routing packets between the host. Connectionless in the sense the session is not established before exchanging the data. Okay, so the delivery is not guaranteed here, because if you are not providing connection, if you are not providing, yeah. So what I have given, like IPv4, IPv6 is a connectionless datagram protocol. This is meant for primarily addressing and routing packets between them. And whenever we are saying it's a, the session is not established before exchanging the packet. Might be lost, delivered out of the sequence, duplicated or delayed. Okay, and it makes use of transmission control protocol for transferring your information from one to another. Okay, and few more concept is there. What is the protocol, and what is the description of the protocol? Because in certain slides I have used RFC 4861, RFC 5942. Okay, for that I brought this which explains what is the functionality behind each and every protocol. Okay, ma'am. So this is the protocol features. So how it would be applied, where we can use it, something like that we will discuss in one class regarding that paper, right? What is the implementation of the particular technology we can implement. Okay, so what is yet to discuss in this module is Wi-Fi. Yeah, Wi-Fi is still we have to do, right? Fine. I think remaining everything we have covered. And uh, let me finish wired communication, and after that I'll tell you what are the, I'll bring few papers, how the protocol is used there. Okay, those discussion will be held in next class. Fine. Yes. And 1 minute more, I'll check the course page and I'll let you know what is it to discuss. I'll tell. Yeah, two more topic is there, MQTT and wired communication. Once you finish the two protocols, I'll tell you how to prepare for your project, and you have to prepare based on that. Okay. So I'm making the document. Yeah, possibly by 1 or 2 days I'll try to upload, right, your batch IDs. And during the review dates, I'll just call you with the batch ID. Who are already can present. I'm coming in the order A batch, B batch, C, something like that. If one of your member is absent, you can't present on the day. Okay, please understand that also. If one of your member is absent for project review, the review will be